In this lecture, we're going to go over the null and alternative hypothesis statements for a two-factor ANOVA. And as we've covered before, the null hypothesis statistical approach here is about setting up for the number of possible outcomes that can be generated from a statistical test. And so with the two-factor ANOVA, we ask the question, what are the possible outcomes? Well, with a two-factor ANOVA, what we have are what are called main effects and interactions. Specifically, with a two-factor ANOVA, we will have two different main effects that we'll address here on slide number 9. And on the next slide, slide number 10, we'll address the null and alternative hypothesis for the interactions. And so if we take a look at the first null hypothesis statement, you'll see that we have H0, but we have A. A in this case refers to the first main effect, the first of the two main effects, and we're just going to label this generically here as main effect A. And main effect A states for the null hypothesis that mu1 dot, so going back to our earlier terminology of an I row and j column, this is referring to the average along the first row, with a dot indicating that it collapses across the columns or combines all the data along the first row of the column. We're going to state with the null hypothesis that this average will be equal to the average of the second row, which is equal to the average of the third row, once again with rows 2 and 3 collapsed across columns, equal out to the number of rows. And so in this case, the rows 1, 2, 3, up to n rows refers not to individual cases, but these refer to the levels of the main effect A. Likewise, with the second main effect B, we're looking at the average of the first column, so this is a dot row and a one column collapsed across all of the rows. So this is essentially all of the data lined up along one column. Combining all those data or collapsing all those data, calculating the average, and the null hypothesis states that that average will be equal to the average of the second column, the third column, out to the number of columns. And as we saw with main effect A, the 1, 2, 3, n columns are the levels of factor B. Once again here referring to the fact that we have two factors in this study. And so just to review this once again here, so for main effect A, we're examining differences between the different rows collapsed across columns. And for the second main effect that we're generically calling main effect B, we're examining differences between the columns, which are the levels along that factor, collapsed across the rows. Now going back to our example, our specific example in our lecture here, we go down to the first main effect, which I'm calling the group main effect. And that group main effect is examining all the data collapsed for the group in the therapy condition versus the control condition. And so what we're seeing here with the therapy average, this is the therapy average collapsed or combined across the pre-test and the post-test. Likewise, this is the average of those individuals assigned to the control group combined or collapsed across the other main effect, which is both pre-test and post-test data are collectively put together to calculate this average. So as a main effect, is this particularly meaningful? Maybe. So we won't answer this question. We won't be able to answer this question right now. It depends upon the other outcomes of the study and the context of the specific research question. Going to our second main effect here, which is the main effect for test, this evaluates the average of all the pretest scores combined for the therapy and the control groups, evaluated against the average of all the post-test scores combined for the therapy and the control groups. And so is this comparison particularly useful? This particular main effect in this example is not uniquely useful because we're collapsing across the groups. And the reason this might not be useful is that the groups here, the therapy and the control, did different things between the pre-test and the post-test. The therapy group engaged in 6 weeks or 8 weeks of behavioral therapy, and the control group did not engage in that behavioral therapy. And so if the statistics find that there's a significant difference, it may not necessarily be particularly meaningful because of the fact that the participants did different things. And so the alternative hypothesis is that we could simply state that the null is false, but because we only have 2 levels of each of the main effects, we could also state this, that mu therapy is not equal to mu control and mu pretest is not equal to mu post-test. Or you could just leave it as H0 is false. Now we have one more null hypothesis to go through, and that's the null hypothesis statement for the interactions. And when we examine the interactions, we're examining how the levels of one factor interact across the levels of the other factor. And so we state this as the null hypothesis of A cross B, or A interaction B. So now what we're doing is we're combining all the levels of both factor into one null hypothesis statement. And so once again, referring back to our system of I rows and j columns, what we're doing here is we're going to compare the average of all the data in the first column and the first row, and that's the control group measured at the pretest, and we're going to examine the difference between that average and the average of the first row, which is the control group, evaluated on the post-test, which is the second column. And so what we're really doing here with this null hypothesis is we're going to compare the difference of the first group across the 2 tests, the pretest and the post-test, against the difference of the second group across the pretest and the post-test, which is the second number, which is the columns here. What I've done here is I've just transposed the mu21 subtract mu subscript 22 to the left-hand side, so our final statement for the null hypothesis of the interaction is stated this way. So it's mu11 subtract mu12, which is the difference, subtract mu21 plus mu22, because we change the signs when we transpose to the other side, and when we run these numbers it should equal to 0. This is what we call in a two-factor ANOVA. We refer to this as a tetrad with respect to the null hypothesis. Now, to be specific to the research study in our running example here, we're going to put a little bit more meaningfulness to this. So we're going to change the numbers to the levels that we labeled for the 2 factors. And so the null hypothesis, instead of stating A cross B, we're going to say group by test. And this is the mu, or the average of all the scores for the control group taken at the pretest, subtract the average of all the scores of the control group taken on the post-test, subtract mu of the average of all the scores of the group of the individuals assigned to the therapy group on the pretest, plus the average value of all the scores of the therapy group on the post-test. And if we were to add if we were to run through the arithmetic of all of this, it should equal to 0. And if it does equal to 0 in theory here, then the null hypothesis would hold, and that would state that there is no statistical interaction at play. There are different types of interactions that could be present if we reject the null hypothesis, and for that reason we would just simply state that the null hypothesis is false for the alternative. So we're going to consider either one of these to not both at the same time with our statistical testing. Now, in the event, and we'll see this a little bit later in the next couple of videos, if the interaction is statistically present, so if after running the statistics, we reject the null hypothesis and we accept the alternative, by accepting the alternative, we're stating that there is a significant interaction. In that event, the main effects are considered to be moot. And in this regard, we reason that we no longer consider interpreting the main effects, although in some cases we can interpret the main effects with a grain of salt, because the main effects are confounded by interaction. And we'll see this in the next couple of videos when we examine the graphs of our sample study examining the effect of a new behavioral therapy technique on happiness in undergraduate students. So this ends this first video here of the different types of, or the two hypotheses for a two-factor ANOVA.